So listen, if you want to do serious circuit board soldering, you want precise control over how much heat you use and where that heat goes. That means you need a soldering station like the Metcal GT120. Why? Because it heats your soldering tip to the right temperature quickly, it holds that temperature exactly, and it quickly recovers to that temperature after transferring heat into your workpiece. Oh, you want one? Well, you're in luck because TechniTool is giving away a Metcal GT120 and it's signed by Mythbusters alum Tori Belici. Right. So if you want one, go check out Tori's GT120 unboxing video first and then enter to win. You can enter at www.techni-tool.com/Metcal-giveaway. And I'll put that all on the screen for you because there's no way you're going to remember to type that all in. And we're going to put a link in there because you want easy access to win that Metcal, don't you? So get going. All right, guys, I'm Nicolette, and today Brian and I are here with Mark Culpepper. He is the general manager of Solar Solutions over at DroneBase, and he's here to talk to us not only about solar solutions or drones, but both of them. So we are in for some fun today. Mark, thank you so much for joining us. We do appreciate your time.
Yeah, thank you for having me. I'm excited to be here. This should be fun.
So before Brian takes over this conversation with drones, tons of drone questions, I saw recently, in the midst of Hurricane Ida, that DroneBase was doing some work during the hurricane. And I was wondering if you could just kick us off and tell us a little bit about what was going on there.
Well, anytime there's a natural disaster or an issue at scale, right, where you've got a lot of problems happening over a broad area, and document or record information that people need. That can be first responders, that can be insurance companies, utilities, you name it, right? So one of the things that DroneBase brings to the table, we have a large network of UAV operators. And sometimes manned aircraft are adequate for kind of a broad view, but you really have to bring the right tool to the table for the right level of detail. And for manned aircraft, they do a really good job filling the gap kind of in between satellite data, which is too coarse, and drone data, which can be very fine resolved. Manned aircraft can do a good job of providing good contextual data per site. If you really want to find out what's going on in a specific location, there's really no better solution than a drone. I like to say low and slow beats high and fast almost every time for very specific detailed information. So our operators work with insurance companies and others to basically get them the data they need when they need it in a really timely fashion.
So now what's interesting about Ida, right? So besides insurance companies, now you guys also deal with power. Were you guys using drones to see where, I read, I think I saw somewhere there were, I don't even know, 300,000 poles down or something crazy like that. I can't remember the number. Yeah. Were you doing stuff with any of the utilities also with the drones during Ida?
Not to my knowledge. I don't think we've done anything with utilities yet for down poles. Mostly the work that we're doing right now with insurance claims. I would say certainly you can use drones for utility inspections, and a lot of companies are doing that now. I don't think we have any active missions right now with Ida for utilities pole inspections that I'm aware of. But quite a bit of work going on the insurance claims, as you might imagine.
Oh yeah, it's crazy, Yeah. Now, so you also mentioned energy, right? And I know we were talking a little bit before, and energy and inspection of energy, and a lot of people believe drones are the way to do it if you're using. So how else is it being done? You mentioned there were other ways that it was being done.
Well, I think, just my own background. So I worked in the solar sector for many years at a company called SunEdison, and I ran global operations and was their chief technology officer. And part of that experience, when you're running a big network of distributed systems, trying to get good data is always part of the challenge. Certainly you have the SCADA data that comes off from your traditional data telemetry, and that's good. But I can tell you, operations centers are typically overwhelmed with information. They have a lot of data coming into them, and what they need is context, right? And so we started a company in 2016 called Precision XYZ, and we were focused exclusively on the solar sector using drones to help kind of throughout the value chain, all the way from early stage development through construction, all the way into asset management, doing thermal inspections on assets that had some problems. And what we found during that process, as we got into it deeper, what we found was that drones are really good for on-demand inspections. They're really good for spot inspections. And they're not as good for annual health inspections. So what an annual health check is, basically, it's exactly what it sounds like. You overfly a site, you assess the site, and you identify defects or anomalies at the site, and then you roll those up into a report. You hand that report over to one of several parties. The challenge with drones and with the industry in general is that you need a solution that can really, really scale, right? There's about 3 million solar plants in the United States right now. They deliver around 100 gigawatts of power as of this year. That's a lot of power. That's kind of like, think of that almost as 100 nuclear reactors, right? So it's a lot of power. But what's interesting is that about 70% of that power is delivered from about 6,000 of those 3 million power plants. So it's really concentrated in these big power plants, right? And that trend's not going to go away. There's a strong impetus in the financial sector to really drive to scale, because the cost of building out, say, a 200 or a 400 megawatt power plant, in terms of your fixed costs, are comparable to doing like a 10 megawatt power plant. So there's a lot of incentive to basically drive toward these big deployments. From the standpoint of aerial data, though, drones aren't really the ideal solution to do, half a gigawatt of power. What you really need, and what we found out having done this for 4 years, is we came to the conclusion that, we need manned aircraft. We need kind of the Ford Ranger of the sky, which is really a Cessna, right? With higher resolution equipment on it, the ability to cover massive amounts of area on a daily basis, and really effectively scale up data collection and processing, so that you can collect a lot of information on these plants. Because if you think about that concentration, right, the 6,000 or so power plants, manned aircraft, with the right fleet, you could cover that entire. Oops, just lost a headphone there, guys. Sorry. You could cover that entire deployment in the space of probably 60 days. I mean, this year alone, we'll cover about 60,000 nautical miles with our manned aircraft. So we're really trying to say to the industry, you need to operate at scale. This has to be easy for the industry to consume. And you can't get lost into the weeds of trying to get a guy in a van out there with a drone. Now there is a role for the drone operator for sure. Specifically for the field technicians, the field engineers, when they need to go out there and really assess something, they want something that they can use as a tool, just as you would use a power drill or anything else. So when they get that annual health check and they look at it, they want to be able to take their drone and say, okay, this is where I need to check. Let's see if there's been anything that has happened in the last 30 days since the health check came done, and be able to fly the drone up, compare those two, and then take action from there. So these two technologies are really complementary to each other. And you really have got to look at them as technologies that allow the industry to operate at the scale that it needs through a really simple single source solution.
Do you find that or are you, I guess here's my question. Are you guys using a lot of AI to help? Because you mentioned there's a lot of data, right? Is there some AI being used to help sort through the data for what's important and what's not? Because, obviously there are things that are, maybe not really relative to what someone's looking for. But my second part to that question is also, does the manned aircrafts actually cut some of that, because there are human beings maybe collecting data or putting some context to the data when they're collecting it with manned aircraft?
Well, I think those are great questions. I think that the short answer is yes. You absolutely have to use AI and machine learning to handle the amount of data that's coming at you, right? And particularly for the solar sector, because if you think about this sector, the need for inspection is highly concentrated in specific time periods of the year. So, for example, the peak earnout period for solar in North America is the summertime, kind of late spring through the summer and early fall. That's when those power plants literally make the most money during the course of the year. So you want to have your inspections done more or less within about a 2-month period at the start of that entire process. So you can imagine all those plants basically have to be compressed, and all that data has to be compressed, processed, and delivered literally like pretty much like that, in a fairly
any time for them to repair anything, right? Also,
correct. So what we've done is and one of the things that are that you can do with manned aircraft, which is really, you can't really do it with a drone right now, is do real edge computing, right? Where you can basically put a lot of processing capacity on the aircraft itself, process the data you collect as you collect it. So by the time that plane lands, it's already uploading data into the cloud that's pretty much complete. You're still going through quality checks, but a lot of the AI, a lot of the photogrammetry processing, in fact, all the photogrammetry processing is happening on the plane, during the flights. And by the time they land, it's really just going up for quality check and final sign off before the reports get delivered. But you could not do this. You could certainly do it in a limited fashion with manned aircraft without AI, but it's going to be, you're never going to be able to plow through the amount of data that you really want to plow through for an industry that's challenged as it's growing and as the needs for solar continue to expand, not only in the US, but globally.
Mm-hmm. So with the manned aircraft, right, in comparison to the drones, what to cover, like, say, the same area, right? You mentioned a manned aircraft could cover like a lot more distance. How many I don't know, and you can give the example, but how many, how many drones would you need to cover the same distance as like a manned aircraft?
Well, to put it in context, we can do a 0.5 gigawatt a day per manned aircraft for large concentrated power plants, big industrial power plants. To do that same amount of area, so a 0.5 gigawatt is probably, you kind of have to think about the math. In general, every megawatt is around 5 acres, right? So when you get to 1,000 megawatts, that's a gigawatt, you're talking 5,000 acres. Now you have to build in some buffer into that as well, because of all the roads and access roads and things like that. So call it 6,000 to 7,000 acres. So when you're at a 0.5 gigawatt, you're around 3,000 to 4,000 acres.
Okay.
That is an enormous amount of space.
Yes.
I mean, it is a large area. When you go out to these big power plants, you're literally in a sea of glass. It's easy to get lost just driving around the power plant. It's like a little city, To do that, to do a 0.5 gigawatt with drones, that is probably, if you're efficient, it's probably a month's worth of work at least. And that assumes that you're getting consistent thermal data. So what that means is, the sun comes up and goes down, obviously, but depending on where the plant's located, you're going to get some cloud coverage that comes in. You're going to have some days that have higher irradiance than other days. If you do it with a manned aircraft, that all gets shot at once. So you get consistent thermal data.
Right, in one day.
Yeah, in one day, and the quality of the sensors is frankly it's better. There's no comparison between the quality of a sensor on a manned aircraft with a drone. Doesn't mean the drone's not useful. It is, but you got to put it in context, right? I mean, you have a cooling system on a manned aircraft that keeps that thermal sensor cool. There's a lot of other variables there.
Right. So what about like, we talked about solar. What about like wind turbines, right? So, I mean, obviously if it's a big wind field, the plane would be, more efficient at doing it. But what about like the details? Like if you want to go up to that wind turbine, that's where you would use a drone maybe to look at.
Yeah. That is a really good question, because there is a big distinction between where you can use manned aircraft and where you can't. And in general, what it boils down to is horizontal infrastructure, big flat fields, work great for manned aircraft. Vertical infrastructure, not so much, because you got to get a lot more detail, right? And for example, with our system, with our wind-based system, you have to do that with a drone, because what they're literally looking at is they're looking at the blade itself, and they want to find defects on the blade before the blade fails. Right. So that process, what becomes important in that process is, do you have the right tech stack? It's really simple, right? If you don't have the right tech stack, you're not going to be able to inspect that blade efficiently. So for our system, when you take a drone to a wind turbine, you're literally going to put in the type of wind turbine. So we have a big database of wind turbines and kind of what the parameters of the wind turbines are. How long are the blades? How wide are the blades, right? What's the variance between the center and the tip? All that stuff. And literally what the operator does is go up, he enters in the code for that type of turbine. They fly the drone up, center it on the nacelle on that unit, and then hit go, and it flies an automated pattern and literally captures every single bit of data.
So you get all your inspection.
You get all your inspection protocols, and they're all standardized, which means they're efficient, they're consistent, they're reliable, they're accurate, right? And they're fast, because you cannot spend, there's some really interesting drone technology out there now that will allow you to literally create a 3D model of one of these systems. But that inspection process can take an hour. These guys have to roll through literally hundreds of turbines. So, our protocol takes 12 to 15 minutes. It's fast, right?
Right.
So,
and you're eliminating like operator error, like some guy going, oh look, there's a hawk over there. Let me go. Let me go.
Big time.
Chase it down, right?
Yeah, because just the small nuanced movements, right? If you have to manually do these things, these blades are sensitive, and if you crash a drone into them, you may be introducing damage to the wind turbine, right? At a time when that is absolutely not what the client wants. What the client wants is something that is simple, reliable, consistent, and accurate, right? So that's kind of our mantra. And I think, if you kind of look at our site, you kind of go back to the Staples easy button. We really are trying to make this easy for the clients, because we recognize, as important as this is to us, to the clients, it's important, but their world does not revolve around it. Our world revolves around aerial data and accurate and reliable collection of data at scale, right? So that concept of a single source, make it reliable, make it consistent, and make it easy for the client, that's a big part of what we do. And the technology stack is kind of built around that idea.
Here's my question. Let's talk about we talked about drones. We talked about unmanned aircraft. Let's talk about energy for a little bit. What insight do you have around energy and where that's going?
Well, in the context of aerial data and just more broadly, kind of what's happening in the energy sector, I think it is really interesting to see the phase of transition we're in. I mean, quite literally, I live up in the Sierra Mountains, up in Truckee, and we're literally on fire up here. I mean, climate change is not a theoretical issue to anybody who lives up here. It's literally become a life and death existential issue, and it's not just here. I mean, look at what's going on. It's literally fire and water, all over the country and all over the world right now. So this transition to renewables is critical for everyone. It's not just, obviously we're interested in it because, let's face it, that's how we make some of our money. But there's a lot of people here who are passionate about it because they see it as important, important transition. Energy transitions are never easy. They're always hard. And the question is, how do you do it quickly?
Well,
I think for the oil, go ahead.
Yeah, and I mean, so many people have talked about this, and I'm just pulling up notes because I was talking to someone else, and they were saying, like, basically they believe like this shift in energy, going to, more environmentally friendly energy is really, I think this, and I was trying to look for the quote, but it's sort of like the sixth industrial revolution, right? It's basically that's the next thing on the horizon, like shifting into these greener energies such as solar, wind, things like that.
Yeah, like sustainability, is kind of the key word there, right? And how do you build sustainable societies? How do you build sustainable infrastructure? We actually know how to do it. Like if you look at what's going on in California right now, California has adopted a lot of renewable energy. They're kind of the leader in it. And just recently they said, you know what, we're going to have to buy some natural gas peaker plants to fill the gaps because energy storage technology has not quite caught up at the scale that wind and solar have, which is part of the gap. You gotta fill the gaps. Now, some of that is regulatory problems. And I think a lot of people, particularly in the energy storage sector, would argue that is primarily the issue. But, it's not just renewables who are kind of wrestling with this challenge. I mean, if you look at what's going on in oil and gas right now, they are really trying to figure out how do we repurpose our mission to solve problems at a larger scale and do it in a way that is going to be sustainable over time. Because I think that the writing is pretty clear on the wall right now that continuing to pump emissions into the atmosphere is not sustainable. So, we've actually worked with companies in the oil and gas sector who are looking at oil fields. I don't know if many of your viewers know, but California has a big oil and gas industry. The entire southern half of our Central Valley is just covered with oil wells. Historically, a huge industry in California. And a lot of those fields now are essentially being evaluated or in some cases actively repurposed as solar fields. And I think this is probably a really interesting thing. You look at areas of Texas, right, where there's a ton of oil fields. Solar is kind of a perfect application in those areas where they need to repurpose them. Same could be said probably for wind too, although wind as a resource is a little more challenged because you have to have specific areas where the wind blows. Solar has that unique advantage.
Yeah.
But I think this entire energy transition right now, Brian, is a fascinating problem and a really great opportunity for a lot of wealth creation, honestly. And one of the things that struck me during the COVID crisis last year, I'm at 6,200 feet, somewhere in that range. So we have pretty clean, beautiful air up here most of the time when the fires aren't burning. And when COVID hit and there was a national shutdown, there was a noticeable improvement in the cleanliness of the air up here. And that's for up here, this is the place where people go for clean air, right?
Right.
And you could noticeably see improvements in air quality. And that's kind of a preview of some of the good things that we have to look forward to. I mean, we got challenges in front of us for sure. But, really clean, pure air, that's one of the things that we will have to look forward to as both as a country and the world, as we go into this transition.
Yeah. What's interesting to me, one of the things I find really interesting, and don't get me wrong, people are, they get an electric vehicle, right? But then they're using like fossil fuels to power the electric vehicle, right? So you're still in essence, I mean, yes, maybe it's a different type of emissions or it's in a different place, but you're still, using, not clean energy to power a clean energy, So if you're going to be, if we're going to be solely green, right, we need to focus on not just like, oh, well, let's have an electric vehicle, but let's just make the energy green to power the electric vehicle, and that's where you start. I think it starts rolling into each other where it makes a lot more sense. And, you'll see a lot more a lot more adoption of it, both technologies.
I think you're absolutely right. I mean, if I think about the challenge of scale, right? I mean, one of the things that the oil industry has done a fantastic job of that nobody can argue with, they know how to scale industry, right?
Right.
They have built literally a global scalable system for delivering wellhead to wheel, as they call it, all the way from the wellhead oil all the way to deliver gasoline to your car, to the point where it's cheaper than, in many cases, or at least it was anyway, cheaper than milk, Now, as we move into this new transition, we are keenly aware that to achieve those same efficiencies, this industry has to automate. By that I mean renewables, solar and wind. They have to automate. They have to operate at scale. And systems like aerial data have to be able to deliver things efficiently and make it easy for people. If it's, and by people, I mean big industry operators, asset owners, things like that.
Right.
They cannot be bothering with a complicated system. So our whole mission and purpose is really to make sure we deliver that data to them in a really efficient and scalable way.
So here's the thing, we saw the oil industries, how old, I don't know exactly, but you could say it's 100
Over
years
100
old,
years.
right?
Over
Right.
100,
So, I mean, hopefully, and we've seen solar around for, solar's been around, and let's face it, electric cars have actually been around for a long time too, 100 years. I think the first electric car was invented, and one didn't take off. And like you said, what really made the oil and gas industry is they're being able to make it a global industry. How far out are we really from doing that with these cleaner energies, would you guess?
Yeah, well, if you look at kind of the adoption rate of solar, I don't think any energy technology has actually been adopted faster, with the exception of probably fire. Right. I mean, seriously, it's right now it's growing around 20% per annum, right? Which is fast. I think to achieve the objectives from the Paris Climate Accords, obviously we need to scale that up, and then the world needs to scale that up. I think there are really a couple of holes in the tent that are more challenging than others. The broad and massive adoption of storage technologies is absolutely critical for this to work. Right. It's not so much a challenge anymore on generation. So you can almost think of it like this, Brian. Like if you look at what happened in the 90s with the internet, what the internet did was it took fundamentally a really dumb telecommunications network and it turned it into a really smart telecommunications network.
Right.
And one of the ways it did that was through decreases in the price of data storage and decreases in the price of transmission. Right. And essentially what's happening right now with energy is kind of the same thing. So the cost of generation has plummeted. There is no cheaper source of generating power right now on the planet than solar. That's a fact. Even without incentives, right? The challenge right now is how do we ramp up storage fast enough to accommodate this change that we have to go through. Right. It's not one of those things where it's like, I wonder if we'll do that. It's like, no, this is a mandatory transition. Fortunately, the economics are very favorable. You can almost think of solar right now as think of it as an oil well with an increasing yield over time. Because if you look at a solar plant that we built like in 2008, where we could get maybe 10 megawatts on a site, that same site today could accommodate easily 15 megawatts. Same footprint, just more power. That trend's going to continue over time, right? So those things are all positive and great things about what we're doing with solar. So I think to your question, how do you scale up that? Well, the first thing is you got to automate. You have to. If you think about the cost of building a solar plant, the cost of building a solar plant is shifting more and more away from the materials piece and more toward the labor piece.
Right.
Because material costs have been declining consistently year over year over year, and the industry has done a phenomenal job at grinding costs out of its systems. The labor costs are still, as a material point, they're actually rising relative to the overall cost of the power plant. So that means that you have to automate. You have to. It's not even like one of those things where you go, well, maybe we'll use drones, maybe we won't. It's like everybody's going to be using drones. And even now, even in the early stage of development and construction, drones are really critical. Drones and aerial data are critical. You could just do things faster and more efficiently. I'll give you another example. When you go out to survey one of these large power plants, we surveyed one of the largest power plants in North America called Gemini, and it's east of Las Vegas. That was about 12,000 acres that we surveyed, and we did that with drones. That would have taken literally months to survey in traditional means. Months. And even if you had surveyed it with manned aircraft, your resolution of data would have been smaller, right? Less accurate, sorry. Not smaller, bigger.
Right.
So what you got was you got a drone-based system that gave you very, very fine granular data and delivered it literally I think our first product delivery out of that was 6 weeks. It took us a week to survey, to literally collect the data. It took us only a week. It would have easily taken, just to get the data collection from a traditional surveyor, at least 6 weeks. At least. Wow. All right.
So
it's an order of, you're just chopping costs out, right? You're just really trying to how do I accelerate things? How do I reduce costs? How do I automate? We have to be relentless about this. And this is one of the things that we are so excited about at DroneBase. We feel like we've got a great platform, and this platform will scale with the industry. I know that. I worked in the industry, so I know exactly how we need to build this thing. And simplicity, automation, machine learning, all these tools go together. Single source, make it easy, make it scalable, make sure you're delivering what the client needs and wants in a timely fashion.
So Mark, where can everyone find more about what you guys are doing over there?
Well, you can go to our website, DroneBase.com. We have breakouts for each of the verticals that we serve. We serve 3 verticals really, and then one kind of, we call it a vertical, but it's really kind of a horizontal. Wind, solar, properties, and then what we call architecture, engineering, and construction, AEC, or EPC in the industrial world, engineering, procurement, construction. You can learn about all of our services there. If you have projects you want to work on, don't hesitate to reach out to us. You can reach out to us through the website. There's a lot of ways to get in touch with us. We're pretty active and becoming more active on social media these days. I think DroneBase has been kind of the sleeper in the space for a couple of years now. And, it's been pretty exciting to be here at this point in time because, our push into renewables and properties in general has really accelerated in the last year and a half. And I have been very excited to be part of that process. DroneBase acquired my company, in December of last year. And it's been just a lot of fun to get into the mix, at scale, because that's really what this is about. It's like, how do we solve this problem? How do we really help accelerate everything? So go to our website, www.dronebase.com.
Mark, thank you for joining us. And I'm sure we're going to be talking more as more and more green energy rolls out.
Yeah, I hope so, Brian. And again, thanks for the time. Really appreciate it. And look forward to chatting again soon.
At a pro baseball game, when a hometown hero hits a grand slam, a lucky fan ends up with an autographed bat. Why not celebrate that same passion in electronics? Technitool is giving away a top-of-the-line Metcal GT120 soldering station signed by Mythbusters alum Tori Belleci. Unlike autographed sports gear, you won't want to leave it in a display case. Check out Tori's GT120 unboxing video. Go to technitool.com/Metcal giveaway and enter for a chance to win. We'll also drop the link where you're watching this or listening to this below.